So one kind of evidence that it's relevant to support a causal claim is the existence of a correlation, sometimes called an association between two things. So I'm going to say a bit first about what a correlation is. It's a kind of statistical generalization. It's a relationship between variables, what I'm going to call variables. A variable being something like a quantity or an attribute that can take on lots of different values. So this is a simple idea. It's not complicated. So an example of a variable is the weight of a person, right? That's a variable that can have weight of a person in kilograms, right? And that's a variable that can have possible values like this, right? Different individuals have different values of that variable. That's a fancy way of saying different people have different weights, right? That's all there is to it. Income per year of a person, that's a variable. Different people have different incomes. It's a variable that can take on different values. Number of students enrolled in a unit, a variable which changes from semester to semester. These ones are all numbers, right? But the values of a variable don't have to be numbers. They could be cities. If we have the variable place where a person lives, city where a person lives, the values of that variable are cities like Melbourne, Sydney, Bendigo. Or you might have a variable which can only is a yes-no attribute variable. So it can take the values true or false, yes or no. Does this person have breast cancer, yes or no? Does this person own an iPod, yes or no? So correlation is a relationship which holds between variables. Suppose you have a group of individuals and you've got two different variables, A and B. And then you make a list that matches up for each individual the value of these variables for each individual. So here I've got height and weight. So this individual, Adrian, has a height of 65.78 inches and a weight of 112.99 pounds. Now, in pounds, not kilograms. And same for all of them. Now, you might find something like this, that people who have higher values of the one variable also tend, on average, to have higher values of the other variable. So people who have a higher height also have a higher weight. That would be then you'd have discovered a positive correlation between the two variables. A negative correlation would be the other way around. It would be when a higher value of one variable goes with, on average, a lower value of the other variable. Right? So here, these red dots in this graph are the data points from this table. So I've just plotted along here height and weight. And so here's one person, and their height is just under 66 inches and their weight just over 110 pounds. And here's another individual. And you can sort of see that as height increases, so does their weight, which is kind of what you'd expect, right? Because they're both measures of the size of the person. This is real data, by the way. Here's the same thing, but from the whole data collection that those 7 came from. So you can see there's kind of a line going, sloping upwards through the points like that. So that's a positive correlation. But it's noisy, right? It's not a perfect straight line. That's okay. This again is a statistical concept. On average, if you pick 2 people and you compare their heights, and let's say George is taller than Peter, then most of the time you would find that it's also true that George weighs more than Peter. Not all of the time, that would be a perfect correlation, but most of the time, on average. That's another way of saying what it means to say there's a positive correlation between height and weight. This concept of correlation only applies when we're talking about variables that have values that are either numbers or can be ordered. There's some concept of higher or lower that you can apply. Right? But remember, not all variables are like that. Some, like this one, Australian city in which you live, or yes or no, they're called categorical variables and attribute variables. There's no concept of higher or lower that applies to the values. Right? Just want to show you a few more examples of positive correlations. So this is positive correlation between two things. The blue is the amount of carbon dioxide parts per million in the atmosphere against time, 1964 to 2008. So you can see it's going up and up and up. Right? And also here we've got global average temperatures, which wobble up and down quite a lot, right? But you can see the general trend is that they're going up too in step with the amount of carbon dioxide in the atmosphere. So these two things are correlated. If you pick 2 years at random and you find that one year has more carbon dioxide in the atmosphere than the other, most of the time you'll find that it's also true that the first year was warmer than the second year. Oh, here's a negative correlation. This is a correlation between, how many dots are there? 3, 6, not 10. So each of these is a student, and it measures the number of hours per week they spend watching TV versus their grade point average. So high grade point average, this person, low grade point average 2, 20 hours a week watching TV. Whereas down here, high grade point average, 3.7 or something, just over 5 hours per week watching TV. And you can see the general trend is down, right? The more TV you watch per week, the lower your grade point average. As you can see, these things are kind of noisy and fuzzy. So statisticians have a way of calculating a number that tells you sort of how strong the correlation is, how near to perfect it is. We're not doing any maths here, I just want you to know this idea. If you see this idea of a correlation coefficient, it's just a number that measures how tight the correlation is between the two variables. A perfect correlation gets a value of +1 if it's a positive correlation and -1 if it's a negative correlation. If there's no relationship at all between the variables, like in the middle, it's just a splurge of dots, right, with no clear relationship, then it gets a correlation coefficient of 0, and then other values in between 0 and 1, 0 and -1. What about these variables where there isn't a concept of higher or lower then? Categorical variables or attribute variables? There's still a concept of association or correlation that applies here. It's basically the same idea, but a little to state it differently. It's somewhat hard to get your head around. What it means to say that there's a relationship between two categorical variables. So what might it be? What kind of thing might we be looking for? Well, let's look at two variables. Say, owns an iPad and religion. Is there any association between those two things? Well, what would it mean for there to be an association between those two things? It might mean something like this. You're more likely to own an iPad if you are Buddhist than if you're not. But that would be a correlation between religion and whether or not you own an iPad. Or it might be that you're much less likely to own an iPad if you say you have no religion. That's the kind of thing we might find. In general, there's an association between two categorical variables, A and B, when an individual who has attribute A is more likely, on average, more likely to have attribute B than an individual who doesn't have A, who's not A. So, more likely to own an iPad if you're a Buddhist than if you're not a Buddhist. When I say more likely, just think in terms of proportions or percentages. So in the example I've been making up, it would be that the proportion of all people, God, it's quite hard to say, the percentage of Buddhists who own an iPad is much higher than the percentage of non-Buddhists who own an iPad. That's another way of saying you're more likely to own an iPad if you're a Buddhist than if you're not a Buddhist. Here's another example. A study looked at drinking habits of several thousand men and women, this is a real study, found that 23% of the men but only 17% of the women were frequent binge drinkers. Let me just pause there. How do they know that? They did a survey, right? What might have been some of the problems with doing a survey to find out from their sample of thousands of people how often you went on a drinking binge? Problems?
Problems recalling how much they drink.
Yes, people's self-estimates of that might not be very reliable because they might not remember. Right? I'm laughing because, of course, frequent binge drinking can lead to memory loss, right? Particularly, so that's a particular problem with this particular study, right? And of course, people just might not quite tell the truth, right? But anyway, let's take that for granted. Here's what they found. 23% of the men, but only 17% of the women were frequent binge drinkers. So that means there's a correlation between two variables, gender, male or female, and frequent binge drinker, yes or no. Someone in this group, anyway, was more likely to be a frequent binge drinker if they were a man than if they weren't. So in this table, the information there is presented. So here we've got, were you a frequent binge drinker, yes or no? So 1,630 of the men said yes, 1,684 of the women said yes. No, just over 5,000 of the men said no, 8,000 women said no. So that means this proportion, this percentage, which is here, is much higher than this. So in this group, you're more likely to be a binge drinker if you're a man than if you're a woman. Notice, though, if you only looked at this, top row, these numbers are about the same, right? So if you only looked at those, you'd think there wasn't any difference between frequent binge drinking in men and women, right? Just as many men say they're frequent binge drinkers as women. But it's because there are many more women in this sample, right? So this because of this number is much higher. So this proportion turns out to be much lower than this proportion. I'm just trying to talk about this concept of correlation or association in a bit of detail because it is important to understand what it is and what it isn't. It's purely a statistical claim, right? It's just percentages, basically, or averages.